precipitate that will be formed when 75 milliliters of 0.8 molar sodium hydroxide reacts with 85 milliliters of 0.75 molar copper sulfate solution. Now we're not given a reaction here, so what we need to do is write out the reaction first. So I've got sodium hydroxide, and I'm reacting it with copper sulfate. As you can see by observation, this is going to be a double displacement reaction. So we've got our copper, which in this formula is 2 plus because of the sulfate, which is 2 minus. And I'm going to combine that with the hydroxide, which is 2 minus. So the copper hydroxide that's produced here is CuOH2. And the other product is sodium sulfate. Sodium has a +1 charge, and sulfate is -2 in its charge, so we produce Na2SO4. Now the question asks us for what mass of precipitate, so we need to identify which one of these is going to be the precipitate. If you use the solubility rules, you'll see, and this is just good for practice, you'll see that sodium hydroxide is aqueous, based on the rule that all compounds of the alkali metals are soluble. For the sulfate, all sulfates are soluble except if they're combined with lead, calcium, strontium, mercury, or barium. So that means that copper sulfate is going to be soluble or aqueous. Copper hydroxide, so rule number 5 is that all metal hydroxides are insoluble except if they're with group 1A, calcium, strontium, or barium. So that means that this is our precipitate. And again, sodium compounds are always aqueous based on rule number 1. So what we have here is 75 milliliters of our sodium hydroxide, and it's 0.80 molar. And then we've got 85 milliliters of our copper sulfate, and it's 0.75 molar. And as you might see or recall, this is going to be a limiting reactant problem. We're being given information about both reactants, so we don't know which one is controlling the reaction. So we need to identify which one is the limiting reactant. So to do that, we can set up our table to organize our data. So we've got our reactant, our moles of our reactant, our moles of our product, and in this case we're going to use the copper hydroxide because that's what we are trying to find the mass of. And then we're going to decide the status of the reactants. So our first reactant here is sodium hydroxide, and our second reactant is the copper sulfate. Before we go any further, we should just balance this. We need a 2 there. So to find the moles of sodium hydroxide, I need to multiply the concentration by the volume, and I need to make sure that I put my volume into liters. So I find that I have 0.060 moles of sodium hydroxide. Same thing for the copper sulfate, the concentration times the volume put into liters, and I am left with 0.06375. To find the moles of the product, I need to apply the ratio. So for the sodium hydroxide, it's a 2-to-1 ratio. So my moles of sodium hydroxide are 0.030. And the copper sulfate and copper hydroxide are in a 1-to-1 ratio. So the moles of copper hydroxide based on the copper sulfate is 0.06375. At this stage, I can see that my limiting reactant is my sodium hydroxide. So the actual amount of product that I can produce in this case is 0.030 moles. In my last step, I can find the mass of the copper hydroxide. So I can multiply the moles of the copper hydroxide that I'm able to produce and multiply by the molar mass, which is 97.57, and I find that I'm able to produce 2.9 grams of the copper hydroxide. So this setup is exactly the same as it was in the previous unit when we studied limiting reactants. The difference is that we're dealing with concentrations and volumes instead of only being given the masses.